Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 18, JWT Anatomy and Pitfalls. Alice, JSON Web Tokens are everywhere. Every tutorial, every framework, every build an auth system in 10 minutes, blog post uses them. What's the actual security story?
JWTs solved a real problem. How do you authenticate requests across distributed services without every service needing to query a central session store? The answer is a self-contained token. You encode the user's identity and permissions into a JSON payload, sign it cryptographically, and the client carries it with every request. Any service can verify the signature locally without network calls.
Break down the structure for me.
3 parts separated by dots. The header, which declares the signing algorithm and optionally a key ID. The payload, which contains claims about the user, who they are, when the token expires, what they're authorized to do. And the signature, which proves the header and payload haven't been tampered with. All 3 parts are base64 URL encoded, converted into a compact text format using letters, numbers, and a few symbols so they're URL-safe strings you can put in HTTP headers.
Right. And the signature is what gives you the security guarantee.
If it's verified correctly, yes. The server computes the expected signature for the header and payload using its secret key, then compares it to the signature in the token. If they match, the claims are trustworthy. Nobody modified them after signing. If they don't match, the token is rejected. The entire security model rests on correct signature verification.
Which brings us to the infamous none algorithm attack.
In 2015, Auth0 disclosed that multiple JWT libraries in Java, Node.js, PHP, and Python accepted tokens with the algorithm set to none. That is a reserved value, meaning this token has no signature. The specification allows it for testing. Those libraries treated it as valid in production. An attacker could craft a token with any claims they wanted. Admin access, any user ID, any permissions. Set the algorithm to none, and the server accepted it without verification. The fix across the ecosystem was straightforward. Reject none. In production, maintain a strict allow list of accepted algorithms, and validate the algorithm in the token matches the algorithm your server expects. But the damage was real. Any system using those libraries before the patch was wide open.
That's catastrophic. How does it happen?
Because many libraries implemented verification like this, read the algorithm from the token header, then use that algorithm to verify. If the algorithm is none, verification trivially succeeds. The fix is simple. Never let the token tell you how to verify it. Hardcode the expected algorithm in your verification call. If you expect RS-256, pass algorithms equals RS-256 explicitly. Reject anything else. Most modern libraries do this by default now, but legacy code and misconfigurations still exist.
There's a more subtle variant too, algorithm confusion.
Yes. Say your server uses RS-256, asymmetric cryptography. It signs with a private key and verifies with a public key. The public key is often published at a well-known endpoint. An attacker obtains the public key, sets the algorithm header to HS-256, HVAC with SHA-256, which is symmetric cryptography, and signs the modified token using the public key as the HVAC secret. If the server reads the algorithm from the header and uses it, it performs HVAC verification with the public key, which is the same key the attacker used to sign. Verification passes. The forged token is accepted.
Yeah, same fix. Hardcode the algorithm. Never trust the header.
Exactly. The header is attacker-controlled input. Treat it accordingly.
Let's talk about token lifetime. Short-lived versus long-lived. What's the trade-off?
Here's the fundamental problem with JWTs. Once issued, they're valid until they expire. You cannot delete a JWT. You can't revoke it without maintaining server-side state, which defeats the stateless purpose. So token lifetime is really a question of how long you're willing to let a compromised token remain usable. A 15-minute access token means even if stolen, the window of exploitation is small. A 24-hour token means an attacker has a full day.
But 15-minute tokens mean the user keeps getting logged out.
That's where refresh tokens come in. The OAuth 2.0 pattern. OAuth being the standard protocol for delegating access, which we'll cover in depth in episode 20, uses two tokens. A short-lived access token, 5 to 15 minutes, sent with every API request, and a longer-lived refresh token, days or weeks, stored securely, used only to obtain new access tokens. The refresh token can be revoked server-side because it's checked against a database on each use. You get the UX of persistent sessions with the security of short-lived credentials.
That makes sense. And refresh token rotation?
Critical. Every time a refresh token is used to obtain a new access token, you issue a new refresh token simultaneously and invalidate the old one. If an attacker steals a refresh token and the legitimate user also tries to use it, one of them will present an already invalidated token. That's your detection signal. Immediately invalidate all tokens for that user and force reauthentication. OWASP recommends this pattern explicitly.
Now, here's the honest question. When should you not use JWTs?
When you need immediate revocation. When you need concurrent session limits, only one active session per user. When you need a real-time audit trail of active sessions. When a user changes their password and you want all other sessions to die instantly. JWTs can't do any of these without adding server-side state. And if you're adding server-side state anyway, you might as well use server-side sessions. Thomas Patekak made this point years ago, and it's still valid.
So for legal SaaS, where you might need to immediately revoke access when a lawyer leaves a firm, or when privilege boundaries change mid-matter.
Stateful sessions are often the better choice for user-facing authentication. You get immediate revocation, activity tracking, concurrent session control, and a clear audit trail. The session ID is a random opaque token stored in an HTTP-only cookie. It carries no claims, reveals nothing if intercepted, and can be invalidated in milliseconds by deleting the server-side record.
Right, but JWTs still have their place.
Absolutely. Service-to-service communication within your infrastructure, where you control both sides and revocation is less critical. Microservice architectures, where your application is split into many small independent services instead of one big program, where a gateway validates the user's session and then issues a short-lived JWT for downstream services to consume without each needing session store access. That's the sweet spot. The pattern many production systems use is sessions for the user-facing edge, JWTs for internal service communication.
What about storing JWTs in the browser?
Never invoked Dopanger. That's a storage area built into the browser that any JavaScript code on the page can read and write. It's accessible to any JavaScript on the page. A single XSS vulnerability and the attacker exfiltrates the token. Store access tokens in memory. JavaScript variables that don't survive page refresh. Store refresh tokens in HTTP-only, secure, same-site, strict cookies. Inaccessible to JavaScript, only sent by the browser automatically. This gives you protection against both XSS and CSRF.
Yeah, quick summary of the non-negotiables for anyone implementing JWTs today.
Hard code the expected algorithm. Never trust the token header. Validate issuer, audience, and expiry on every request. Keep access tokens to 15 minutes maximum. Use refresh token rotation with reuse detection. Store tokens in HTTP-only cookies. Never local reporters. Rotate signing keys annually with overlapping key IDs. And ask yourself honestly whether you actually need JWTs or whether server-side sessions would serve your security requirements better with less implementation complexity.
Next episode, session management. The server-side approach we just advocated for. How to do it right, from ID generation through lifecycle to invalidation.
Until then, I'm Alice.
And I am.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.